cities are a relevant entity on the entire Earth. In the moment we have 50% of the global population live in cities, and we see that this process is accelerating, so it is expected that 2020 we have more than 60% of the global population in cities. Cities are the location of wealth. We have most of the assets there. They are vulnerable in terms of potential climate impacts. Large cities we have in the coastal band, so for instance the Gulf of Bangladesh or Gulf of Bengal in particular. But cities are also the main emitter of emissions. So it's estimated that 70% of all the global emissions comes from cities. So that means, in other words, when we like to tackle the climate change challenge adequately, we have to focus on cities. We have very, very different definitions. Some of the definitions focus more on functional aspects, others are focusing on the people who live in a certain entity. So, and most of the statistical data available for cities is related to administrative entities, while on the other hand, cities are not standalone entities. So we have exchange between the vicinity and probably with twin cities. Therefore, we decided to look on parameters like built-up areas, and we try to classify this with an automatic algorithm. And by the help of this algorithm, it is feasible to identify all urban clusters globally. When you compare this with the administrative boundaries, you see a huge difference, and for the heat island effect, this is in particular relevant because the difference is quite large for some cases. So, and we did it for 130,000 cities European-wide in the first step. It was feasible to identify 7 different clusters, so that means 7 different city types in Europe and in the Mediterranean region, which showed us different kinds of heat islands. Yeah? So during the annual cycling, we have cities which we have in the Mediterraneans. For them, we really expected a pronounced heat island effect, but they showed us that there is even a cooling effect during the summer seasons. Paris over the years shows a pronounced heat island effect. Madrid shows during the late summer and in fall a decrease of the temperature, which goes below 0, and that means we have a cooling effect. And this cooling effect is quite important for us because this is related, of course, at least particular to the infrastructure composition in the city, but not alone. So we know also some kind of interrelation between dry land and vegetation inside of the city. This is called oasis effect. For the intensity of an urban heat island, the material which is used inside the city is of particular relevance because concrete, asphalt have a heat storage capacity which is, for instance, quite larger than heat storage capacity of natural land, for example. This approach allows you to provide vulnerability maps. So when you have a better resolution, you can immediately provide insights in which quarter of a certain city the heat burden is larger in comparison to others, for example. So this is in principle feasible already now.